All right, welcome to the video for 10.1, areas of parallelograms and triangles. So parallelograms would obviously include rectangles and squares as well. I'm going to give you some formulas you probably already know, but there might be a few tricky things here in the notes, so make sure you take good notes so that you're ready for any challenges that the homework might bring. So being able to find the area of two different shapes. First thing, you should probably know this one already. The area of a rectangle is the same as the area of a parallelogram, which is the same as a square, but we do have one more specific formula for that. Whether it's a rectangle or any type of parallelogram at all, the formula to find that would be the length of the base times the height. So when you're finding area, you're finding really how much area inside of the shape. So we want to know how much space that takes up. So when we talk about area, we're talking about how long the base is, how long the height is for a rectangle or a parallelogram. Multiply them together to figure out how much space that rectangle would occupy in square units. Same exact thing with a parallelogram. They're the same shape. If I were to take this triangle here and translate it over here, it would land here, and what I would have is a rectangle. So they're actually the same exact shape, so the same formula could be used, which is base times height once again. So the base of a parallelogram can be any of the sides. The altitude is wherever the right angle is drawn. This is going to be true no matter what shape we're talking about. Whatever the right angle is touching, that's the base. All right, so since the right angle is touching this side or adjacent to that side, we have the base right here. So the base could be any of the four sides. The height is the height from that base to the other side of the rectangle or parallelogram. Okay, so they might give you some values that you might not actually end up using. So for this example, we have a 4.5 here that doesn't really do anything. I see a base right here. I see a right angle. So I'm going to use the height of 4. With the base of 5, I'm going to get rid of the 4.5. So since we're in inches here, the area of this rectangle is just base times height. We're going to do that a lot where you just write down what the formula is before you plug things in, which is just 4 times 5, which is 20. Area, again, is square inches. Okay, same thing down here, and feel free to rewind or rewatch anything that I show you. I see the right angle here, which would go with this base. So I'm going to use a base of 2, a height of 3.5. Ignore the 4.6 then. So area is base times height. So we have 2 times 3.5 or 7. This time we're in centimeters squared for our area. We'll use a capital A for area all the time. Okay. So as far as parallelograms go, base times height. I could make it a little bit trickier by not giving you one of those values. So let me show you that. Here we're missing a value. We already know the area, but we're missing a value. So they want to know the length of DE. So find DE on the shape. That would be DE. That's a height. So they want really what the height is. They want to know what the value of the height is. What they did give us is they gave us, well, this is the height that would go with this value, the 9.4, okay? So they didn't give us the area. Sometimes they might, but they gave us enough to get the area another way. I see another height over here. This height is 9. This height would go with this side, which is 13. So the area of the parallelogram is just base times height. Well, one base of this parallelogram is 13, and the height that goes with that base is 9, so this really is 117 square inches for the area, which is not the answer, but that's helpful. Because if I know that this 9.4 now is another base. So I could say that the area is base times height. I know that the area is 117. So if 117 is the area and 9.4 is the base, I can figure out what h is. So all I need to do really is take 117 divided by 9.4. I have it worked out just so the video goes a little faster. If you do that in your calculator, you should get 12.4 or in inches for the height. So 12.4 times 9.4 would give you the same thing as 13 times 9, which is 117. Okay, so sometimes you might be missing a dimension. Okay, that's going to be good for our parallelogram stuff. Let's look at area. Let's see. I have about 5 minutes left to get through this, and that should be plenty of time. So triangle formulas. Any triangle is just half the area of a parallelogram. The reason is right here, if you've ever wondered why that works, but you can rotate a triangle right on its midpoint. So I'm taking this triangle and rotating it. And if I kind of draw that triangle in, they're exactly the same size because rotation would be an isometry. What you're doing is you're copying the triangle. Any triangle can be copied and kind of turned like that to just make a parallelogram or a rectangle sometimes. So really the area is base times height for this one that we just made. Well, half of that base times height is going to be just the triangle, just what we want, this stuff, the stuff that's really getting taken up. So a lot of the same stuff is true, but you can use base times height over 2. I know a lot of us like that formula, or we can use 1/2 base times height. They're exactly the same thing. Whatever you want to use is just fine with me. So I can take you through some easier ones, but I'm going to show you one that's a little trickier right away. We're going to find the area of this triangular sail. They want to know how many square feet of material do you need. They're saying what is the area of the sail. That's the question. So they gave us a base, which is 13 feet and 4 inches. They gave us a height, which is 12 feet and 2 inches. We have to take that and run with it. So what I'm going to have us do here, first off, is figure out how many each one of these dimensions are in inches. So if you take 13 feet, 4 inches, take this 13 times 12, and then add the 4 inches to it. That's 156 plus 4, or 160 inches. Converting that into inches. Converting this one into inches, we should have 12 times 12, which is 144. So we're going to take that part, multiply by 12, then add the 2. This is 144 square inches, or just inches, not square inches, sorry. Okay, so now that I have this in inches, that's much easier to figure out what I need here. So right now, I have area is 1/2 base times height. Okay, and what I have here, I can get an answer in square inches. So let me finish this example up because there's one other trick to it, and then I'll show you there'll be one short video for the rest of it. So for right now, this is going to give us an answer in inches, but 1/2 times 160 of the base, 146 of the height. If you do all that, that's 11,680 square inches, which is a great answer, except for they asked for square feet. Okay, so this is kind of tricky, but I need to convert square inches into square feet. So I need to turn that into square feet. Kind of tricky right here. I know that 1 inch is 1 foot, that's backwards. 1 foot is 12 inches. Okay, so I need to know how many square feet. If I'm looking at 1 square foot, how many square inches that would be. Okay, so really 1 foot is 12 inches. If I square both of those to get my square feet, 1 squared is still 1. 12 squared is actually 144. So I need to take this 11,680 and I'm going to take it, divide 11,680 divided by 144. That will actually give me my square foot answer, which is 81.1. So if I need square feet like area in this instance, a lot of us would take that answer and divide by 12 because that's how many inches are in a foot. But we actually need to divide by how many square inches are in a foot, which is 144. Another way to think about this one, and then I'll have you switch to the next video here really quickly, is that a square foot is 12 inches by 12 inches. Well, the inside of this, then, this is 144 square inches, which is 12 times 12. So if you have to go from square inches back to square feet, divide. All right, let's finish off the 10-1 notes here. You have an example about finding the area of an irregular figure or a figure that you do not know the area formula for. There's this house-looking shape, doesn't have a good formula to get the answer every time. But what I see are two different shapes that I do know the area for. I know that I have the area formula for the triangle and for the square below. So really, if you get an irregular figure, you're taking area in a couple steps and then adding the results together. So if we find the area of the triangle first, I have this dotted line here with a right angle, meaning that 8 is the height of that triangle. So I have the 1/2 part, I have the height part, I need the base. The base is right here of the triangle. The length of that should be the same as the lengths of the sides of the square. Since it's a square, all these tick marks mean that each side is congruent. So there's a side length of 6 right there. So 1/2 times 6 times 8 should be 24 square inches. That would be your formula and your answer for the area of the triangle on top. The area of the square underneath it is just base times height, which is 6 times 6. So down low you have 36 square inches for the square below. So then the area, the total area, is just those two added up. So the 24 plus the 36 added together. So all in all, this irregular figure has an area of 60 square inches. So irregular figures can get kind of crazy. Break them into shapes that you know the formula for, and then take it from there to find the answer. Add them all up to get the total at the end. Okay? Last thing I'll show you, kind of a trickier problem here. They gave us a ratio of the sides. Okay? So right there they gave us the base to the height. They're saying that the base to the height ratio is 5:3. So we know, we've kind of done problems like this. We also know that the area is 135 square millimeters. Okay? What we need to do is find what B is and what H is. So as we look at doing this, we know that base times height is 135. It's a parallelogram, so that's the area formula, base times height. All right, well, we don't know what base and height are. That's what we want to find, but we know that 5 times something times 3 times that same something is 135. We've done these with addition before. I'm going to add an x to each of these in the ratio to try to figure out what x should be. If I can figure out what x is, I use that to figure out what the side lengths are. So let me show you that. Right here, if you multiply these together, 5 times 3 is 15, x times x is x squared. So then I can solve this by algebra. So I'm going to divide both sides by 15. X squared is then 9. Take the square root of both sides to figure out that x is 3. So x is 3 is not the answer, but that helps a whole lot. Back to what I said. The ratio is 5x to 3x, or 5 to 3. So if x is 3, then the ratio is 5 times 3 to 3 times 3, or 15 to 9. Remember, ratios are only ratios if they're completely simplified. 15 to 9 should simplify right back down to 5 to 3. But let's check this answer. 15 times 9 then should be 135, which is true. All right, so what that means is that to finally get the answer, the base of this parallelogram must have been 15 millimeters. The height must have been 9 millimeters. So if you get problems like that, try to add x's to the ratio and see if you can figure out in the end what the base and the height would need to be. That wraps up 10-1. So that's just parallelograms and triangles. This entire chapter is about a whole bunch of different types of shapes and how we would find their area. So I would go up to the front, up to the desk, get a worksheet from the sub, and I'll be back tomorrow to answer some of your questions. Good job. Work hard today.